Hi everyone, welcome to our YouTube channel. In this channel, all we'll be doing is solve advanced and complex engineering problems. So these are what we'll be doing here, and there are problems that are found on big sites like check.com, Course Hero, so and others and so on. So these are the questions we'll be solving, we'll be providing solutions to them. These questions are questions that normally when you search online, search on Google, you have to pay some of amount to either checks or Cause Zero or other sites to access the solution. But here you are getting them for free. You are getting them for free. So the first question we're looking at here is the one on which the picture has already been posted. So you'll be seeing it as well. You can see that that question is on checks.com. So we took it from checks.com. So we'll be providing solution to it right now. So let's proceed. So now the first question says a distance traveled by a comet in the space given by an equation of s is equal to 5t raised to power 5 minus 5t raised to power 4 plus 3t plus 12. So where s is measured in meters and t in seconds. The first question, which is A, it says we should find the what? The velocity as a function of time. Then the B part, it says find the acceleration as a function of time. C, which is what is the velocity and acceleration after 10 seconds. So now the first question say we should find the velocity. In order to find v of t, velocity v of t. So in order to find this, all we just need to do is find the first derivative of the position function s of t with respect to time. So we are going to differentiate s of t once. We are going to differentiate it once with respect to time. Then that will be our velocity for this problem. So now s of t once again is 5t raised to power 5 minus 5t raised to power 4 plus 3t plus 12. So now we are differentiating it just once, the first derivative, which is down there, v of t equals to ds over dt, which is you can write as 5t5 minus 5t4 plus 3t plus 12 over dt. So all we just need to do now is differentiate this term singularly. We are differentiating it term by term. So what we just need to now apply the power rule of differentiation. So you go ahead and do this. So in case you are wondering what have I just done, what I did was by applying power rule, you multiply when you want to differentiate, you multiply the power with the coefficient of the term, then you subtract 1 from that power. That's what I just did. So 5 times 5, then I subtract 1 from the power, on the power of 5. So I'm going to apply the same thing to the rest. So 5 times 4 t 4 minus 1 plus this 3 now, this 3t, t has a power of 1, although the power is not written there, but we can see that it's raised to power 1 even though it's not written. All we just need to multiply it by the coefficient as well, then subtract 1 from it. Then this 12 is a constant. When you differentiate a constant, it is 0. You get 0, so plus 0. So now we add them up. 5 times 5, that is this is 25, give us 4, give us 23, yeah, plus 3. So we have just gotten our velocity. So this is our velocity for the question that we are asked to find. So our velocity is 25 t raised to power 4 minus 20 t power 3 plus 3. But don't forget, they say we should use the correct unit. So what's the unit of velocity? The unit of velocity is meter per second. So all you just need to do is write meter per seconds in it. So that is it. This is for A. Now for B, without wasting much of our time, for B now, we are asked to do what? We are asked to find the acceleration. For B, find the acceleration as a function of time. And to find this acceleration, it is the same process as we did for velocity. The same process. All we just need to do is, we differentiated position function to get our velocity. Now we'll be differentiating our velocity function to get our acceleration. So a of t, to do that, it will be a of t equals to dv over dt, which is the 25t minus 23 plus 3 over dt. Now we are going to do this the same way, the same differentiation process we apply in the section A. So let me shift so we can all see this clearly. So yeah, I think this is okay now. So now we continue solving our problems. Now let's differentiate time by time as well. So 25 times 4 power 4 minus 1 minus 20 times 3 power 3 minus 1. And once again, this 3 is standing alone. This 3 is a constant, so it will be 0. So applying our mathematics, 25 times 4, that will give us 100. Then t 4 minus 1, that is 3. Then 20 times 3, that will give us 60. 3 minus 1, that is 2. So then is 0. So this is our acceleration for the question asked. And don't forget as well the SI unit, the unit which is meter per second square. That is the SI unit for acceleration. So now going next to the last question, which is the C section. The C section says find the velocity and acceleration. So we're finding the velocity and acceleration v and a after 10 seconds. After t is equals to 10 seconds. So all we just need to do is now or go back to our A question and our B question, then plug in the value of t. So that will give us our final answer. So for A, recall recall shift this again so we can see more clearly. So recall our v of t is giving us 25 t power 4, 20 t power 3 plus 3. So now all we need to do is to insert all we need to do is insert our t is equals to 10. So then we go ahead, velocity now is equals to 25 t power 4 minus 20, that is 10 power 3 plus 3. So applying this and pressing our calculator, we will end up with the value 25 to at least 250,000 minus 20,000 plus 3. which will give us 23,003 meter per second. So, this is our final answer. So this is our velocity in terms of numerical value. So same thing we're going to do for the acceleration part of it. That is a of t. We said a of t is 100 t raised to power 3 minus 60 t square. So now applying t is equals to 10, we have 100 t raised to power 3 60 t raised to power square. I'm pressing our calculator. We should have 100,000 minus 6,000. So then our final answer, now is 94,000 meter per second square. So that is for our A. So this brings us to the end of this lesson, of this solution. So you subscribe to get more of this kind of advanced solution to all these our advanced problems. Thank you very much. Please subscribe and like.